At 3:17 inches the morning, deep in the silent Mojave Desert, the world changed and almost no one noticed. The massive radio dishes at NASA's listening station in Goldstone, California, were doing what they had done thousands of times before, scanning the darkness of space for faint whispers of radio energy drifting through the universe. Engineers on the night shift watched their consoles with the calm familiarity that comes from routine. After all, these were the same scans they had run more than 10,000 times. The sky was quiet, the equipment steady, the data predictable. Then suddenly, a signal appeared. Not noise, not static, not the random hiss of cosmic radiation that normally fills the universe like white paint splashed across an infinite canvas. This was different. The signal repeating across the screen was structured, organized, almost mechanical in its precision. It cycled with such perfect mathematical timing that the senior engineer monitoring the system leaned back from his console and said something that would later be quoted in internal reports again and again. "That cannot be natural." The team immediately began checking the instruments. Calibration perfect. Noise filters clean. Every possible technical malfunction was examined and ruled out. The next step was standard procedure. Cross-reference the signal with the massive catalog of known cosmic radio sources. Pulsars, magnetars, quasars, solar plasma, bursts over 1,700 pages of documented phenomena. The software compared the signal against every known pattern in milliseconds. Nothing matched. And in that quiet control room, during one specific moment before sunrise in the California desert, something inside humanity's understanding of the universe shifted, because whatever was producing that signal was not something we had ever seen before. The date was October 17th, 2025. The coordinates pointed toward a distant object already causing intense debate among astronomers. It had entered our solar system from interstellar space, arriving from somewhere far beyond the boundary of our cosmic neighborhood. Scientists had named it 3I, Atlas, the third confirmed visitor from outside our solar system ever recorded. And it was already strange. Long before the signal was detected, researchers had noticed behavior that didn't fit any natural model. Its trajectory showed subtle course corrections no ordinary comet performs. Its density appeared too high for an asteroid. And instruments had recorded jet emissions even though the object was more than 420 million kilometers from the sun, far too distant for the heat required to drive that activity. But on that October morning, the mystery crossed into something far more unsettling. The object didn't just drift silently through space anymore. It transmitted. The structure of that transmission stunned everyone who examined it. The signal appeared at a stable frequency and slowly increased in intensity over 5 continuous hours. What began as a broad broadcast, spread across space, gradually narrowed until it formed a focused beam directed with extraordinary precision straight toward Earth. Within minutes, the data triggered internal alerts across multiple space agencies. Emergency analysis teams were assembled. Classified communication channels opened. Something out there was sending a signal, and the signal did not behave like anything produced by nature. The implications were impossible to ignore. One of the most respected astrophysicists in the world would later accuse the global scientific establishment of freezing in place, not because they lacked evidence, but because they were afraid of what the evidence might mean. And then the situation became even stranger. 9 days before 3I Atlas would disappear behind the sun, vanishing from the view of every telescope on Earth. The object made one final maneuver. Its timing was astonishingly precise, perfectly aligned with the orbital geometry of the solar system. It was almost as if the object knew exactly how much time remained before it would be hidden from observation. Almost as if it had something to say before the curtain closed. From the perspective of theoretical physics, and particularly the frameworks used to understand how intelligent systems might encode information across cosmic distances, the 12 days that followed may represent one of the most important sequences of events in human history. Not because we discovered something, but because something discovered us. To understand why the signal detection was taken so seriously, we need to understand the instrument that detected it, because the technology behind that discovery is itself one of humanity's greatest scientific achievements. The system responsible is NASA's Deep Space Network, a global array of enormous radio antennas designed to communicate with spacecraft traveling billions of kilometers from Earth. The network operates three massive facilities positioned roughly 120 degrees apart around the planet, so that at least one station always has line of sight to any point in space. One complex sits in the Mojave Desert near Goldstone. Another operates outside Madrid in Spain. The third stands in southeastern Australia near Canberra. Together, these facilities create a continuous listening system capable of detecting incredibly faint signals. Some of the dishes are 26 meters wide. The largest, the massive DSS-14 antenna in Goldstone, stretches to 70 meters across. Its sensitivity is so extreme that it can detect a radio transmission with the power of an ordinary household light bulb from a distance of 16 billion kilometers. This is the same network that maintains communication with Voyager 1, humanity's most distant spacecraft, now traveling more than 23 billion kilometers from Earth, while transmitting with just 23 watts of power, less electricity than the bulb inside a refrigerator. And the Deep Space Network hears it clearly. That is the level of precision we are talking about. So when the system detected a signal it could not identify, the automated verification process activated immediately. Every incoming transmission is compared against known spacecraft frequencies, terrestrial interference patterns, pulsar signatures, magnetar bursts, and solar plasma oscillations. On October 17th, the system completed its analysis. The result came back with a single conclusion: no match. What the network had captured was a repeating electromagnetic pulse cycling every 47 minutes. Each pulse lasted exactly 11.3 seconds. Not approximately, not within a margin of error, but precisely 11.3 seconds every single time. The engineers checked their instruments again, then they checked them again. The numbers did not change, and when physicists began analyzing the structure inside those pulses, they discovered something even more astonishing: patterns within patterns, layers of repeating information embedded at multiple timescales. What they were looking at was not just a signal, it was architecture. And 3 days later, the object that sent it did something even more impossible. It aimed directly at Earth. What the engineers and physicists saw inside that signal forced them to confront a possibility that most scientists spend their entire careers hoping they will never have to seriously consider. The pulses arriving from 3I, Atlas, were not random bursts of energy. They contained structure, layers of repeating patterns nested within one another like intricate gears inside a machine. Within the 11.3-second transmission window, analysts discovered a second rhythm, repeating every 1.7 seconds. Inside those smaller cycles were even faster modulations, oscillating at fractions of a second. It looked less like a natural phenomenon, and more like a carefully organized hierarchy of signals. One senior radio engineer described the structure in simple terms. It resembled a Russian nesting doll made of information. Each layer contained another pattern inside it, more detailed and complex than the one surrounding it. In telecommunications, this type of signal architecture has a very specific name: multiplexing. Multiplex transmission is one of the most fundamental principles of modern communication technology. It allows multiple independent streams of information to be embedded within a single carrier wave by modulating different characteristics of that signal, its frequency, phase, or amplitude across different timescales. Every cellular network, satellite broadcast, and deep space communication system on Earth relies on multiplexing to transmit large amounts of information efficiently. But there is a critical detail about multiplexing that makes this discovery so unsettling. It requires an engineered transmitter. Nature does not multiplex signals. Astrophysical phenomena produce emissions through physical processes such as plasma interactions, magnetic field disturbances, or rotational energy. These events generate radiation, but they do not create layered communication structures that carry independent information channels simultaneously. The signal from 3I, Atlas, clearly did. As scientists began modeling the signal mathematically, the probability of a natural origin dropped rapidly. Yet the most extraordinary evidence did not come from the signal structure alone. It came from how the signal changed over time. During the 5 hours following the initial detection on October 17th, the strength of the transmission increased by more than 300%. At first glance, that might sound like a small technical detail, but in physics, it presents a serious problem. Radio waves traveling through space obey a simple rule known as the inverse square law. The intensity of a signal decreases with the square of the distance from its source. As an object moves farther away, its signal becomes weaker. If the object moves closer, the signal becomes stronger. But 3I, Atlas was not approaching Earth. Its trajectory placed it on a departure path, moving outward through the solar system and away from our planet. Under normal circumstances, that motion should have caused the signal to fade. Instead, the signal grew stronger. The only explanation consistent with the laws of physics was that the source itself was increasing its transmission power. Something inside the object was drawing energy and actively amplifying its broadcast. In other words, something was powering up. The response within NASA and partner space agencies was immediate. A multidisciplinary task force formed within hours, bringing together experts who rarely share the same room: radio astronomers, cryptographers, artificial intelligence specialists, and engineers experienced in classified military communications. Their mission was straightforward but daunting: eliminate every possible natural explanation before allowing the data to advance to the next stage of analysis. For 72 hours, the team examined every detail of the signal. They modeled plasma physics scenarios, simulated magnetospheric interactions, and tested every conceivable astrophysical process capable of producing radio emissions. None of them worked. Finally, the analysts summarized their findings in a single probability statement that quietly circulated through the scientific teams involved. The probability that the signal was artificial exceeded 99.7%. To understand why that number mattered so much, consider how discoveries are evaluated in physics. Scientists use statistical thresholds to determine whether an observation is real or simply a coincidence in noisy data. A confidence level known as 3 sigma, corresponding to roughly 99.73% certainty, is widely considered strong evidence that a phenomenon is genuine. The signal from 3I, Atlas, crossed that threshold, but the most profound detail in the entire dataset had not yet been discussed publicly. It wasn't the regular timing, it wasn't the nested patterns, and it wasn't the increasing signal strength. It was the frequency. The transmission was centered at 1.42 gigahertz. At first glance, that number might appear random, but to anyone familiar with astrophysics and the history of interstellar communication research, it carries enormous meaning. The frequency corresponds to a phenomenon known as the hydrogen line, a radio emission produced when the electron inside a hydrogen atom flips its quantum spin orientation relative to the atom's proton. This tiny transition releases a photon with a wavelength of exactly 21 centimeters. Hydrogen is the most abundant element in the universe, making up roughly 3/4 of all normal matter. Because of that abundance, the 21 centimeter emission line appears everywhere in the cosmos. Astronomers use it to map galaxies, trace clouds of interstellar gas, and measure the structure of the universe itself. But beyond its importance in astronomy, the hydrogen line has long been considered something else entirely: a universal beacon. In 1959, physicists Philip Morrison and Giuseppe Cocconi published a groundbreaking paper proposing that any intelligent civilization attempting interstellar communication would likely transmit near this frequency. Their reasoning was simple and elegant. Any technologically advanced species studying the universe would inevitably discover the hydrogen line. Because it appears everywhere, it provides a common reference point that transcends language, biology, and planetary environments. If a civilization wanted to announce its presence in a way that another intelligent species could immediately recognize, transmitting at this frequency would be the logical choice. It would say, in effect, "We understand the physics of the universe, and we know you do too." For decades, scientists involved in the search for extraterrestrial intelligence have focused their instruments near this frequency. One of the most famous mysterious signals ever recorded, the WOW signal, also appeared close to this region of the radio spectrum. Astronomers sometimes call this part of the spectrum the water hole, a quiet band between hydrogen and hydroxyl emissions where cosmic radio noise is minimal. Symbolically, it represents the place where civilizations might gather to listen for one another. And in October of 2025, the object passing through our solar system transmitted directly inside that band. Through every analytical framework scientists possess: information theory, astrophysics, and communication engineering, the conclusion pointed in the same direction. Choosing 1.42 GHz was not random. It was deliberate. Before anyone had even begun decoding the signal's contents, the frequency alone suggested something remarkable. Whoever or whatever sent that transmission wanted it to be recognized. But 3 days after the first detection, the event took a dramatic turn that made even that realization seem small. Because the signal stopped broadcasting in all directions, and then, for a brief moment in time, it focused into a narrow beam aimed directly at Earth. And then the signal changed. Not slowly, not in the subtle way natural phenomena usually evolve. The transformation happened suddenly, the way a flashlight beam sharpens when someone twists the focus ring from a wide glow into a tight, concentrated point of light. For the first 3 days after detection, the transmission from 3I, Atlas spread outward like a typical cosmic broadcast, radiating energy in every direction. But on October 20th, at exactly 11:15 p.m., Eastern Time, something extraordinary occurred. The signal collapsed. What had been a wide, omnidirectional emission suddenly tightened into a narrow beam of electromagnetic energy. The change lasted only 8 minutes and 24 seconds, but during that brief window the physics of the situation shifted in a way that no natural object could reasonably explain. Because natural radio sources do not behave like spotlight. Pulsars, for example, emit sweeping beams caused by their rotation, like a cosmic lighthouse. Magnetars release violent bursts that radiate outward in all directions. Even the most energetic astrophysical phenomena scatter their energy broadly through space. A narrow, stable beam requires something very different. It requires engineering. Specifically, it requires a phased array system, multiple transmission points synchronized with extraordinary precision so that their radio waves combine constructively in one direction while canceling each other everywhere else. It is a technique widely used in advanced radar systems and modern communication networks here on Earth. Nature does not build phased arrays. Intelligence does. The data confirming this shift came not only from NASA's Deep Space Network, but also from independent observatories around the world. One of the facilities verifying the measurements was the historic Arecibo Observatory, whose legacy instruments were still capable of analyzing deep space radio emissions with remarkable sensitivity. Engineers at multiple observatories ran the same calculations, comparing signal strength, beam width, and directional alignment. Each team arrived at the same conclusion. The beam was not drifting randomly across space. It was locked on a moving target. That target was Earth. The alignment precision was so extreme that the statistical probability of a random natural object pointing directly at our planet during that specific observation window dropped to a number scientists typically describe with a single word: impossible. Something out there had calculated our exact position. Something had turned to face us, and the timing made the event even more unsettling. When analysts examined the orbital geometry of 3I, Atlas, they realized the beam transmission occurred exactly 9 days before the object would disappear behind the Sun in what astronomers call solar conjunction. During this period, the intense glare of sunlight blocks all telescopes from observing objects passing close to the solar line of sight. For roughly 3 weeks, every instrument on Earth would effectively go blind. The object's final directed transmission happened just before that observational blackout began. Almost as if it knew the window was closing. Almost as if it wanted to ensure the message was delivered before the opportunity vanished. For 8 minutes and 24 seconds, the signal remained precisely aimed at Earth. Then, just as suddenly as it had formed, the focus beam dissolved back into a broader transmission pattern. And 9 days later, the signal stopped entirely. On October 29th, the monitors inside multiple space agency control rooms around the world displayed something unusual. Instead of the expected signal analysis data, the systems registered a single operational classification that almost never appears during normal research activity. Restricted. No press briefings followed. No scientific papers appeared in the days immediately afterward. Normally, a discovery of this magnitude would ignite an explosion of excitement within the global research community, astronomers publishing preliminary findings, physicists debating interpretations, researchers posting data analysis late into the night. But this time there was silence. For 5 days, that silence stretched across multiple agencies simultaneously. Scientists spoke privately with one another, but almost nothing reached the public. The absence of information created an atmosphere of tension inside the scientific community because everyone understood the implications of what had been detected. Eventually, one voice broke the quiet. A highly respected astrophysicist, one whose career included decades of research and numerous awards, published a carefully worded statement that spread rapidly through academic networks. In that statement, he did not accuse his colleagues of dishonesty. He accused them of hesitation. According to his assessment, the scientific establishment had become trapped in what he described as institutional paralysis, not because the evidence was weak, but because the conclusion it pointed toward was profoundly difficult to accept. The signal had all the hallmarks of intentional communication. Its timing was mathematically precise. Its internal structure contained layered modulation patterns consistent with advanced transmission systems. Its frequency sat directly on the hydrogen line, one of the most universally recognizable markers in physics. And finally, it had focused a directed beam toward Earth during the last observable moment, before disappearing behind the sundae. Each individual piece of evidence might have been dismissed as coincidence, but taken together, the pattern became difficult to ignore. Within theoretical physics circles, some researchers began referring to the event informally as the signal theory. Not a confirmed explanation, but a framework for understanding the possibility that the object had not simply emitted radiation. It had communicated. Whether that communication contained information intended for humanity or whether it was simply announcing its presence to the cosmos remains an open question. The data recorded during those 12 days in October continues to be analyzed by teams around the world, and the full meaning of the signal may not be understood for years. What is clear, however, is that something unprecedented occurred. For the first time in recorded history, an interstellar object passed through our solar system and produced a radio transmission whose structure strongly suggests intentional design. Whether the source was a probe, an automated system, or something even more complex is still unknown. But the possibility that intelligence beyond Earth briefly reached out across the darkness of space is no longer confined to science fiction. It is now a subject of serious scientific investigation. And if the signal from 3I, Atlas, truly was a message, then the most important question facing humanity is not whether it happened. The real question is whether we understood it. If this discovery fascinates you and you want to explore more mysteries of the universe, make sure to like this video, subscribe to the channel, and share your thoughts in the comments below, because the search for answers has only just begun.